Hello my dear students, today we are going to learn the concept of Venturi meter. What is the function of Venturi meter? Which are the different equations associated with Venturi meter that we will see today. And keep in mind, Venturi meter, which is the application of Bernoulli's theorem. Right. So first of all, what is the function of Venturi meter? So I am writing over here. Function of Venturi meter. The function is to measure. It is a device to measure the flow speed of incompressible liquid. Right. So the function is to measure the flow speed of incompressible liquid. And here we can see the figure of a Venturi meter. This is our Venturi meter. And here we can see this is manometer attached with this Venturi meter. And you know the function of manometer is to measure the pressure of a gas that we have already learned in previous videos. Right. So here we have also indicated 2 points, point 1 and point 2. And in manometer we have different fluid filled with. Here this is fluid with density rho, and here this is mercury, means fluid with density rho m. Clear? And this is the difference in height in level of both the fluid, which is indicated as h. And here we are going to consider two different areas in Venturi meter. Broader area will be like this in Venturi meter, and the pressure of this flowing fluid is P1. Area of this particularly in Venturi meter is A, and velocity for flowing fluid that we will consider is V1. And here this small area, small a, is also considered over here, having the pressure P2 and velocity V2 as shown in figure. Right. So first of all I am writing over here what we have, so it is easy for you to understand. It consists of tube with broad diameter and a small contraction at the middle as shown in figure. Right. Here we can see the broader diameter will be like this. Here it is, and the small contraction will be at middle of this Venturi meter. Now a manometer in the form of U-tube is also attached to it. Right, here we can see the manometer which is attached with this Venturi meter with one arm at the broad neck point, here it is, one arm which is connected to the broad neck point of the tube and other at construction which is known as throat. So this much area is known as throat. So here the second part means the other end is attached over here, means attached with throat. The manometer contains a liquid of density rho m. So here we can see manometer having the liquid having density rho m. Manometer contains liquid of density rho m. Now at point 1 means here it is. At point 1 cross sectional area, what is the cross sectional area? Which is capital A. Cross sectional area is A and velocity of liquid which is V1. Similarly, at point 2, here it is, at point 2, the cross-sectional area small a and velocity of liquid and velocity of liquid is V2. So this is our area A, pressure P1, velocity V1. Now let's apply the equation of continuity. So according to equation of continuity, so what is the equation of continuity? According to this, according to in Venturi meter, we have the area capital A and we have the area small a and velocity V1 and V2. So from that, A into V1 which is equal to small a into V2, and from that the equation for V2 which is A into V1 divided by A. So this is the equation for velocity V2. Now let's apply the Bernoulli's equation over here. So according to Bernoulli's equation, what we can write at point 1 and 2? So P1 plus half rho V1 square plus rho G H1 which is equal to P2 plus half rho V2 square plus rho G H2. Here we can see the center of this Venturi meter, right? So if I draw the line from the center of Venturi meter which is also from the center of the cross sectional area capital A and small a, and from that we can measure the height h, and that will be the equal, means h1 which is equal to h2 in this case in Bernoulli's equation, and from figure of Venturi meter we can write h1 which is equal to h2, but here h1 equal to what? h2. Now if the h1 which is equal to h2, now rewriting this Bernoulli equation, p1 plus half rho v1 square plus rho g h1 which is equal to p2 plus half rho v2 square plus rho g h1. I am writing h2 which is equal to h1. So this term and this term will be cancelled out, and finally if I will simplify, so what will have? p1 minus p2 equal to what? Half rho v2 square minus half rho v1 square. Clear? So this will be the equation, and again I am simplifying this equation. I am writing over here, so p1 minus p2 equal to half into rho, and I have the equation for v2. Here it is. I have the equation for v2, so I am putting the value of v2 in the Bernoulli's equation. So half rho into v2 square, so v2 which is equal to a v1 divided by small a, so a square into v1 square divided by small a square minus half rho v1 square, and finally we will get p1 minus p2 equal to half rho v1 square in bracket a minus a by a whole square minus 1. So you can simplify in this manner, and here we can see this area is very small compared to this area. So here the area A, capital A, which is much greater than small area A, and so that, and hence if the area is large, then automatically velocity is small. So according to that relation, so velocity v1 which is less than velocity v2, and so pressure p1 which is greater than pressure p2, and this pressure difference cause liquid in arm 1. Here this pressure difference cause liquid in arm 1 coming down and in arm 2 liquid rise. Right. So here the pressure at this point is low. At point 2 the pressure is low, and at point 1 the pressure is high. So what will happen? This pressure is exerted on this liquid, so the liquid in arm 1 means at this point coming down like this, and in arm 2 the level of liquid rise. Right. So due to the height difference, the equation of pressure difference will be, now we know due to the height difference we will have the gauge pressure. So due to height difference the equation of pressure difference which is P1 minus P2, which is equal to what? Rho m g h, right? So this is the equation of P1 minus P2, rho m g into h. Now comparing this equation with, we have two equations, which is P1 minus P2 and this one is also P1 minus P2. Let's compare it and find out. Let's give the equation number 1 over here and equation number 2 over here. So equate equation 1 and 2. So what we will get? So from that we have half rho v1 square in bracket a square. If I simplify this, a square by a square minus 1, which is equal to rho m g h, and finally half rho v1 square in bracket a square minus small a square divided by a square, which is equal to rho m g h. I have just simplified the equation, and in the form of v1 square the equation will be a square into 2 rho m g h divided by rho into a square minus small a square, and finally v1, which is equal to under root of 2 rho m g h divided by rho into a square minus a square. So this will be the equation of velocity v1. So here we can write a square over here. So this will be the equation where v1 is the speed of fluid at white neck, right? So this is the Venturi meter, and here we have derived the equation for velocity v1.